What's up, Stat World? Your girl Ham Dog here. We're gonna do some intervals with 2 samples, but before we get there, let's get a graphic organizer going. All right? Get yourself a blank piece of paper, fold that guy in half. I better stop playing this because of copyright. Don't want to hear all the song because then I gotta pay. You know what I mean? All right, YouTube. Okay, so you got your paper folded in half so we can do a little side-by-side comparison for a 1 proportion interval. So I'll put 1 prop Z interval. And the side-by-side, the new formula for today, it's going to be a 2 proportion Z interval. 2 prop Z interval. All right. So what we saw yesterday was this catch, right? We're trying to capture in our net. P hat was holding the handle, and we're trying to capture P. And you always want to start with defining what it is you're capturing. So P equals true proportion, and then I'm going to put in brackets context. All right, so whatever your problem is about, you need to insert it there. All right, so true proportion in context. Over here, when you have 2 proportions, that just means holding the handle. You have 2 friends, right? You're going to have P1 and you're going to have P2 holding the handle. All right, and we're going to try and capture what the true difference is between these 2 groups, right? These 2 different samples that we're going to be drawing. So let's say you wanted to know the difference between, I don't know, men and women, or maybe you want to know the difference between dogs and cats. Meow. So anywho, when you have 2, it just looks like this. P1, P2, and you define what those 2 things are. So you would say, all right, P1 is the true proportion of, and then you could say whatever the context is, right? The true proportion of dogs that, I don't know, are cool. And then P2 would be your second grouping. So you would define it, whatever it is. It's the true proportion of whatever your context might be. All right. So once you define what it is you're trying to capture, then you might want to go through your gatekeepers. All right. Both of these are going to have similar, if not the same gatekeepers. It's got to be random. And for random, you're usually writing that it's stated, or you might have to assume it. All right, so random, it needs to be stated or assumed, and that's the same for over here. So I'll just put little ditto quotes, all right? So then the next thing that you gotta check is the normal. All right, Jake from Stat Farm. Jake from Stat Farm. I'm wearing khakis. You have to do the discount double check. So when it's a 1 single proportion, you just do what we've been doing, n p hat greater than or equal to 10, and n times 1 minus p hat greater than or equal to 10. Remember, we don't know what p is. We're trying to capture what the truth is. All we have is a sample p hat, so we have to use that sample p hat down here when we're running through our checks. For the 2 samples, so this is going to be new over here, your normal check looks very similar, but you gotta do it twice, right? You gotta do this for P1. You gotta do this for P2. All right, so the normal check for 2 proportions takes a minute, and it's really annoying, but it's not hard. So you do N1 times P hat 1, make sure that's at least 10, so you want 10 successes in that first group. And then you check failures, n times 1 minus p hat 1, at least 10, all right? Then you go and you check group 2, so you take your sample size for group 2 and make sure you have at least 10 successes. And then you take the second group, 1 minus p hat 2, and you make sure you have at least 10 failures. All right. If everything passes, then you have that beautiful Billy Bell curve and you can proceed. If it fails, still proceed if it's free response. Don't stop the problem, right? Don't stop, you gotta keep going. Okay, the third thing that we gotta check is independence. INDEPENDENCE. Woo! I have to sing it to spell it. Is that weird? Nah. All right. So to be independent, they have to tell you it's independent. If you're flipping a coin or rolling the dice or spinning a spinner, yeah, each of those is independent. But if you're sampling people or things, sometimes you might accidentally double dip if you're not doing with replacement. So for independence, sometimes you might have to do this little 10% condition check. And that is 10n has to be smaller than or equal to your population size, right? You don't want to overdo it, right? You want that to be smaller than the population. For 2 samples over here, yeah, same idea. You got to do it twice. You got to check it for the first population, and then you got to check it again for the second population. All right, so if you're comparing dogs and cats, right? Dogs, cats, bananas or apples, who knows? All right, so you want to make sure you check both things out when it's double duty to proportions. All right, so once you check those gatekeepers, then you can proceed to the formula. Formula time. So yesterday we saw this formula trying to capture the true P. You start with your point estimate, right? You start with your sample P hat. And then you add or subtract the margin of error. The margin of error is when you take the critical value, which was the Z star, and you multiply it by the standard error. We call it standard error instead of standard deviation now because we have to use P hat, right? It's P1 minus P hat all over N, giant mansion square root. There you go. All right, it's not the standard deviation anymore. It's standard error because P hat. Right? We're using a sample. We don't know the truth. Okay, so let's get a little bit of vocab on here so that you've got it. You don't have to keep flipping through notes. This is called the mo. Oh. Human outside. If he looked in the windows right now, he'd be very disturbed. Okay, Lily, I see it. Human, thank you. All right, so we've got margin of error. This is not standard deviation, it's standard error. We can abbreviate standard error, SE. You'll see it like that in your textbook. All right, and then P hat, that's your point estimate, AKA your statistic. All right, that's your stat that you're pulling off of. All right, so what does the new formula look like? That was yesterday, now we need today's. So today, we are comparing the difference between 2 groups, right? So the difference between two groups. All right, so it starts off with P hats again, but we've got 2 of them. So we've got P hat 1 minus P hat 2, right? We want to know the difference between our 2 samples that we took. Then it's time for the margin of error. So margin of error, plus or minus. You still use Z star, and this is going to be even bigger than that one because we have to squeeze in 2 of these P hats instead of just a single P hat. So hopefully you didn't write too large and we can make it fit in here. All right, so we've got P hat 1 minus P hat 1 all over N1. So it looks a lot like the standard error formula for 1 proportion, right? There's the 1. But now we're going to add in that second grouping. So now we're going to add in P hat 2. 1 minus P hat 2 all over N2. It looks brutal, I know, all right? But all you have to do is show the substitution. Once you show the substitution, then guess what? That's right, Peppa, T.I. Joe, we get to type it in and get our answer. So it'll be pretty easy once you show the substitution. All right. The vocab is still the same. This side is called the mo. All right, the mo. You've got your critical value, you've got your standard error, you've got your point estimate, aka statistics. So it's all there. Okay, so if you want to make note to yourself on this graphic organizer, that when you go to Stat World and you go over to test, this is going to be test A. So I'll put like a little thought bubble around it. Stat World, go over to test. This is going to be test B. All right, and the names of these tests, I don't feel like rewriting it. It's up here. 1 prop Z interval and a 2 prop Z interval. All right, that's what these are. Okay, once you get your answer, then you have your go-to sentence that you're going to write out. We are blank % confident. That blank can change based on what the problem wants. Do they want 95%, which is the most common, or do they want 99%? I don't know, all right? So you just have to read the word problem to know what % confidence level we're going to be setting these as. So we are blank % confident. The interval from blank to blank captures the true proportion of, and then I'll put a little context here. So whatever your problem is about, all right? You're trying to calculate the true proportion of people that watch Frozen 2 many times. That would be me. What is that little thing they sing? Yeah, you know what I'm talking about. Go watch it if you haven't seen it. Frozen 2 is awesome. All right, so your sentence over here, almost the same thing. We will say, we are blank % crazy, normal. No, we are blank % confident. The true difference, I guess I should write out the full word, difference between proportions is between blank and blank. And then of course you want to sprinkle in context, right? What is your problem about? So we're blank % confident. The true difference between proportion is between blank and blank in context. Instead of between, let's try and keep the words the same so your brain has an easier time with it. Is captured, right? Is captured between the interval. You can play around with it, all right? But the idea is you talk about what your level of confidence is. You say you've captured what the truth is. You don't want to talk about your sample anymore. When you get to the concluding statement, you're talking about the population as a whole. So yeah, that's the highlights. So now that we have the graphic organizer, the next video is going to be us or me, hopefully you're playing along, doing problems with the 2 prop Z intervals. All right, so keep this handy dandy, and I'll see you in video number 2 with some practice. Ow!